major area to harvest the energy. Now we are looking for the energy. The other side we are looking for the battery. So this way, then semiconductor, the nanoparticle is playing the major role right now in the nanotechnology. Then some of them oxide material. Here and there, some of the few nanomaterial is playing the major role for medical technology, medical field. There are different shape, very different shape. Okay, so this is what in the with this very simple example you can able to understand. When you prepare the same gold nanoparticle at 40 degrees centigrade, you will be getting one color. At 5 degrees centigrade, you are getting the different color. Okay, this kind of thermo responsive gold nanoparticle you can get. Why? Because of the size is different. When you approach, when you adapt particular temperature, particular stirring speed, particular concentration, particular reducing agent, when you keep on varying those factors, certainly you will be getting the different size. The size, particular why this once is a size is differed in the noble nanometals, certainly you will be getting the different color. That is why 40 degree, once this nanomaterial is prepared at 40 degrees centigrade, you are getting one color. The same nanomaterial is prepared at 5 degrees centigrade, so you are getting the difference. This is one of the best example. So I borrowed some publication. Okay, then as I said before, the different shape and it's an anisotropic AU nanoparticle. You can make it different shape of the nanoparticle. When you prepare the different shape, then you can also not only size, the shape also if are getting differed, then you will be getting different color. Okay, for that purpose I am showing this slide. I think all of you might be familiar what is surface, plasma, and resonance. Okay, so the specific wavelength of light, collective oscillation of electron and the gold, not only gold, silver, platinum, gold nanoparticle surface, cause phenomenon called surface, plasma, and resonance. However, the light irritates a solution that contains dispersed nanoparticle, which is smaller than wavelength of light when depending on the electric field of light. So that is called the surface plasma resonance. So when you take the nano measurements from the atoms, so next is a molecule, next is comes nano, 10 to the power -9 meter, 1 by million. So this way, then all others is comes in the bulk category. Okay, so even the 2010, these fellows, Andre and Constant, they are both are from physics. They have got the Nobel Prize. So invention of the graphene. So why I want to purposely show this slide, this CNT, as I told you, carbon nanotubes. That unfortunately I'm not covering the CNT for this lecture. Carbon nanotubes is one of the important nanomaterials for the energy harvesting. Okay, so that way they are the pioneers for CNT, the graphene, particularly in the graphene. They have the different all electronic applications. Since it's a carbon is a conducting material, that is why that will come all electronic materials. You can very well you can use the carbon nanotubes. So that way current research is going on. The people are using some green sensors, people are using for the LED application, renewable energy, nano remediation, biosensor, health application. So like the way there is a lot of things. So one of the important application is quantum dot. So I'm going to show, not in depth, I'm going to show some of the slides on the quantum dot. So just to make it understand, wherever the band gap is very high, that is a quantum dot. Band gap is very less, that is a bulk material. What we are able to see the naked eye, that is a bulk material. When you want to have the microscopy, electron microscopy, transfusion electron microscopy, so that is certainly there is a band gap is very high, that is why the size is very small, that is named as a quantum dot. Okay, so this way the quantum dot it's getting very small size, that is why it's then as well as it's occupying so many. These are the different quantum dots what I prepared in our laboratory, manganese zinc sulfide quantum dot. When I introduce a UV light excitation at 310 nanometer, each quantum dot it shows a different color based on the size based on, because most of the quantum dots the size is less than 10 nanometer actually. Okay, that is very small size of Nanomaterials may be more than, you can prepare 1 nanometer or 10 nanometer. Most of the semiconductor nanomaterial, if it is less than 10 nanometer, that is you can claim that that is a quantum dot. You can use for the different purpose. So that way, then we are prepared for the particular biosensor application. We use quantum dot for the attached the histidine. Then from that we have detected that dopamine, one of the compound dopamine. Okay, so this way, the dimensionality to control the light, electricity, heat, you see. So this way, then we have the wide application is existing. So quantum dots is wide application for telecommunication, security, and then solar, light emitting diodes. But it will consume less energy. It will consume less heat. It is this way it will be having the less the lumens. So this way that will be playing the major role right now in the market, in the semiconductor industry, this in the electronic industry. So this way, and the quantum dot is playing the major role. So other some of the sunscreen based nano, it is a very interesting. Just I have some slide over there. Sunscreen based nanoparticles. So why we are worrying about sunscreens? The skin damage, which is particularly, it will damage not by infrared, not by visible, UV, ultraviolet is a dangerous. UVC, UVA, UVB, UVC is dangerous. How we can control these things? How to avoid the sunlight to reach sunlight, which is mixture of the rays is comes, one of the rays in the UV rays, particularly the UV A, B, C, how to control this. So that way, you see, the UVA, UVB, UVC is a penetrate into the skin. It will be damage the skin. It will be cause cancer. That is why just we want to have some sunscreen lotion, particularly the people are working with the zinc oxide, titanium oxide. To this zinc oxide or titanium oxide, it will prevent the UVA, B, C rays. Prevent. It will be reflect. It will be fall on your skin. It will be automatically. It will not penetrate over your skin. So that way, nowadays the sunscreen lotions is along with the nanoparticle, oxide nanoparticle, particularly for oxide nanoparticle. They have the colloidal suspension. So that way the people are using. So this is the mechanism behind this. Most of the inorganic, this is the inorganic ingredients along with the organic one. Okay, so this way either zinc oxide or titanium oxide. Okay, so those nanomaterial will be, the size is about 10 nanometer to 300 nanometer. The optimized size they have. So this size, it will be reflect the UV rays, particularly UVA, UVB, UVC, which is dangerous for our skin. Okay, this way, then when you use a bulk zinc oxide based sun lotion, then you will be getting white. But when you go for nano size, it will be transparent. That is the advantage as well as. Okay, this way. So some of the application. So then recently, then one of the application they have used the nanobionic light application. They have used the semiconductor based material along with they have grown along with they injected some of the solution over the when you grow the plant. So they are keeping these things over like a table lamp in their table. So you can see how they are doing the injection over the plant. Can see this the few seconds video how they Okay, this way, this is a very interesting invention which is happening in the Massachusetts Institute of Technology. Okay, so this way the innovation is coming. The designs also is very important. So one of the design is self-assembly. Self-assembly is a part of the nanotechnology. Okay, there's, as I said, the iridescence color, that is also kind of self-assembly. We are, the nature is having this kind of self-assembly. Then not only nature, so we are every day, in the kitchen also we are doing this kind of self-assembly. When you cut the okura for pieces, after some time it becomes arranged by some order, because it is due to the water surface attractive and capillary interaction. So due to this event, it will be arranged some order, that is also kind of the self-assembly. So this way, then the food material nowadays, the people are going with the surface nano patterning. So over the to preserve the food. So safer way the people are using. So this is another one is that this is for the catalyst, so zeolite catalyst. So to arrange the zeolite catalyst, zeolite seeds, the proper assembly. So they are doing some steam stable aluminum silicate structures assembled from zeolite seeds with the help of this is a surfactant. CTAP is one of the surfactant. Using the CTAP, they are arranging some because is unordered structure is ordered structure. For that is a CTAP is very useful. So once it's arranged, after that you can do the calcination. Calcination means nothing but heating. Once it's the heating, all those the organic molecule of surfactant, it will be goes off. Then you will be getting the ordered zeolite seeds. Well, for this kind of design, it may be useful for some of specific catalytic application. So this way, the self-assembly is one of the self-assembly is one of the important area in nanotechnology. So then you can mimic a lot of colors over the self-assembly. So this way, this is one of my paper, visible detection of, so one of the bioprobe for the different biomolecules to detect the different biomolecules. Then as well as I prepared some of these kind of color chips, whether the silicon, then once you heat the silicon at a different temperature, I'm getting the different colors. Just I want to mimic some color, whether it's possible in the laboratory or not. Okay, when I heat at different temperature, I'm getting different colors surprisingly. So then I see why this is the ordered pattern of silica is deposited over the silicon. So in presence of oxygen, silicon becomes a silica. So that way, so I'm getting when you increase the temperature, different temperature, the quantity of oxide layer will be keep on is increasing. The pattern may be very close or very high. So that is the way then I'm getting this kind of color. So just I the out of it is I want to prepare some color chips. That is why I tried. The same thing I did with the, the organic molecules. When I use the spin coating, I prepare different color chips. And these are the things is possible when you go for these are the base I worked for the sensor application. Okay, so that way I prepared some of the chemical sensor. Then I used some of the peptide coated chip for detect the one of the hazardous chemical. So the N-butylphenol. When I increase the concentration of the N-butylphenol, I'm getting the different color over the chip, because this quantity of the hazardous material, it will be disturb the self-assembled order. That is why I'm getting the different color when I increase the quantity. This is not only qualitative basis sensor, this is a quantitative basis. This is the way we are trying to fabricate the sensor in the laboratory to make to bring the market. So whether it's possible to bring the visible sensor, this kind of visible sensor, as you know, then we are every day we are using the pH paper. That is pH paper is prepared. This is one of the innovative sensor, okay, which is from the seaweed. Okay, so like this, whether it's possible to bring the visible sensor. So uh, that way we have not only inorganic material, we played with some of the organic, not only organic peptides, some of the biomaterials. So some of the DNA target based sensors also is available in the market. How to detect the DNA, particular DNA. So this ways, the self assembly is playing the major role. So then, if you want to prepare the very simple self assembled monolayer over the lab, over the beaker, over the chip, then you can do the very simple way. Usually, when you want to have this kind of self-assembled manner, the arrangement, the head is hydrophilic, the tail is the hydrophobic. So that way, then you have to choose some molecule. Then you have to modify some molecule. If you have the nanoparticle, you have to modify the nanoparticle like this. Then you can attach over this, over this the template. So each one they don't have any interaction, that will be go and attached over the surface. So there is some intermolecular interaction which is existing. Okay, so this way, that without any agglomeration, it will be arranged is a very good manner. It's like this way, then you can prepare the monolayer over this pattern. So when you talk about the self assembly, when you talk about this kind of monolayer, then we are supposed to recall the Langmuir and Platchett. The Langmuir Platchett is one of the famous deposition method which is existing. So to make the multi layers, then you can go for the different application, anti-reflection coatings, which is very essential, self-assembled monolayer by Langmuir-Platchett method. Okay, so the conditions when you are taking some molecule for Langmuir-Platchett method applications, you supposed to be the amphiphilic molecule. One side is hydrophobic, other side is hydrophilic. So this way you're supposed to select the molecule. You can do this kind of monolayer deposition. So that way, then you see this for a while, then you see you can able to understand how the LB deposition is taking place. So this way they are spreading the molecule, amphiphilic molecule over the water. Then it will be compressed. Then it will be arranged. The dispersed monolayer, it will be arranged over the water. It is the molecule is supposed to be not soluble in water. So that way, when you spread, then certainly you will be getting self-assembled monolayer. You can get it. Like this way, you can stack multi-layers over this. You can use for the different sensor application. This way, uh, then I worked some of the areas along with Blatchett method for the deposition of the monolayer. You see, like this way, then when you do the reverse, then you can take second layer, third layer, fourth layer, like this. You can do the n number of layers. You can do it like you can stack the monolayer like this. This is also for the biosensor application. Okay, so then when you talk about this kind of intermolecular interaction is existing, so these are the attractive forces. Sometimes they have some of the repulsive force. They balance each other. From this, then you can enrich with successful monolayer coating. You can get it. Then you can do the multi-layer, as well as when you go for the multi-layer at different numbers, then you're supposed to get the different colors. Since it is the refractive index is more than 1.5, you can get some colors. So from this, what I tried to use for the sensor application for this. Okay, so not only that, then you can go for a lot of the light emitting diodes, low threshold lasers, planar display devices. Some sometimes you can use for functionalized C60 fullerene. C60 is a fullerene. Okay, when you do some functionalized the nanoparticle, then you can do for the different applications. So that way, the self-assembled monolayer for the different device application they used. The report is I have taken from China. This way, even I did some of the fabrication in our laboratory to fabricate the sensor in the laboratory. Mm. So whenever we are talking about the sensor or the color sensor, and there is whether it's possible to have the real time, as I said in the first slide, is simplicity. Okay, whether it's possible to go with the real time sensor, label free sensor, portable sensor. I supposed to take this sensor like a PH paper, whether it's possible. These are the challenges which is existing in biosensor. So that way I contributed some of the work for the biosensor. fabrication. This is very good. Even nowadays, the food quality and safety for detection for the enrich the quality and safety. This kind of sensor is very useful for the toxins, pathogens, heavy metals, pests and pesticides, carcinogens. This whether this compound is existing in the food or not. So that way, that type of sensor is contributing a lot. Then I worked in the coffee sensor. Coffee, one of the microbes will be contaminated the coffee. So whether it's possible to detect the coffee, the microbes over the coffee using this kind of color sensor, I worked particular product to detect the pathogen over the coffee. Okay, not only that, then nowadays they are mimicking the butterfly wings. As I informed earlier, the butterfly wings uh, butterfly wings to secure the currency, to duplication of the currency. Nowadays, the technology is going up. Now the technology going up to minimize the currency duplications. So currency forgery. So they are adopting they want to adapt the butterfly faced color, iridescent color. So this way, then as well as natural based green nanotechnologies also is coming up. They will use a natural extract, flower extract, bark extract, leaf extract, and then fruits extract. They people are using to prepare the nano because so that way then we can minimize toxic effect over the nanoparticles. So that way the people are using that is called as a green synthesis. So sometimes they will use a honey mediated green synthesis of nanoparticles for the safe nanotechnology. And so that way, then as well as then we have some report. I think this is one of the plant that is this plant weed. This is a weed actually. It is called as a Neyveli Katamanaka. That is a common name in our place. This weed extract. This is the only extract you can prepare the nanoparticle in room temperature. When you have this extract, when you have the AgCl, AgNO3 or AgCl3, then you can immediately you can get the nanoparticle. So this way, this is a very strong reducing agent which is existing. That is why just purposely I want to add this slide. So not only usually when you are preparing nanoparticle, you're supposed to need some temperature, some stirring, some temperature, some concentration is required. For this, so not at all is necessary for the temperature. Even the room temperature, it will pop the nanoparticle. And this way, this extract is very powerful. So when I prepare the AG nanoparticle. And I worked with chitosan, the nanoparticle, AU nanoparticle. I prepared using the chitosan. So this way, then with this, I will finish the first part of my talk. Maybe the second part. Then I will go with the most of the medical. What is the role of nanotechnology in medical based application? This is what I'm going to discuss. If you have any doubt, any things as a part of the interaction, then you can interact with me. Then I'm ready to answer. So then I will go for the next. I will go for the second part of my talk. Hello, sir.
Sir, we continue after 5 minutes or 10 minutes.
Yeah. That's right. That's right. Yeah. I will come back. Thank you. Thank you. Shall I start, sir?
Professor, we continue the session.
Yeah, yeah. Okay, sir. Yeah, that's right. I'm waiting. Yeah. Now the second part, I'm going to talk about, as I said, the some of the medicinal application where it is, because as I am the entrepreneur, I am using the pharmaceutical medicines. I'm using the nanoparticle for this, and as well as some of the application I'm using for agriculture application. So how the nanoparticle is influencing for agriculture, the other side devices, some of the medical devices, how, what is the role of nanomaterials. So this way, these are the topic I am going to discuss for this part. And then as well as the how the startup is enhanced for the product development, as a faculty members, how to you encourage the students to come up with some startup, to bring the students to think out of box, out of classroom, how to do this kind of activity towards students. So that way, I believe that the second part of my lecture will be useful for particularly for your students. So when you encourage your student to motivate your student to become the entrepreneur. Okay, this way, whenever we are talking about, so far we have discussed some of the issues, whenever we are talking about nanomaterials, nanotechnologies, so some of the techniques, some of the material fabrication, nanomaterial fabrication, the design is very, very important. So that way, the innovation and the design is playing the major role. Whenever we are talking, whenever we are claiming that I am the nanotechnologist, I suppose to do some innovative way, I have to prepare the nanomaterials. Innovative way, I have to go for the nanomaterial preparation or fabrication. Then as well as I have to make some design. The innovation and the design is very, very important. That way, I am going to show some examples. You see, this is one of the individuals, the student contribution. This is okay. So the Malawi, they don't have the Malawi, they don't have for his home, they don't have any electricity. So for that, he made his house is the using the second hand material. Then he prepared his house getting electricity. Okay, by using the homemade windmill to produce electricity. This way, these are the events, so inspiring us to innovate something, to design something, to because nowadays is a very big demand for the energy. The other side is very big demand for the medicals. So this way, whether we have the chance to the contribute, so as a faculty members, so the chance to contribute those kind of things to pass your message to the students. So I'm talking out of the syllabus. I'm talking. Okay, so then only they can make our students to innovators. So this way, this student, this is just school out student. Then he you see the next one. I'm not going to show the video. The next one, you see what are the parts he used, all the second hand parts, the old parts. He used all those things, shock absorber, the PVC pipe, bicycle generator. He assembled everything. He made it the homemade the windmill. The windmill is generating the electricity for their house. So for the single light, to charging their mobile, for charging their radio, so they are using. So this way, then even the individual students, they have the contribution in the global level. Okay, here and there. This kind of concept always our Abdul Kalam is encourage the students to contribute this kind of idea, this kind of event. Then another one example, just this girl. I think you might be heard about this Vinisha. Then he innovated. Then the nice way. Then he innovated the how to avoid the iron. Usually they will use the coke, no, to coke. So for them they will cheaper, but it will cause lot of pollution, and they create more the toxic air pollutions in the environment. Then as well as for them it's very hard to use as well as. So this way, she is a ninth standard student. She has keep on watching these kind of things nearby his house, her house, so in Tiruvannamalai. Then he started to innovate something. So then he designed the solar photovoltaic cells over this tricycle. Then from that she is getting the electricity. Then he is helping those guys to provide the iron box by the photovoltaic the system. So this way, then she has got a lot of prize recently. She has got a lot of the green based the winner for the global prizes. So that way, then she's showing some. So that's where then she has got the global prizes. So these are the news is motivating us to create something, to innovate something. Okay, so that way then we mimic some of the event in the even the laboratory. So we have prepared the nanoparticles, the gold nanoparticle and silver nanoparticle in the different way to for the different applications. So these are the outside of the lab, outside of the campuses. We are seeing many events here and there. Whether it's possible to give the solution for them, whether it's possible to give the some innovative material for the community base. Usually, when I started my research career, then I will do for the whether my research is useful for the community. So this way, the innovation will start. Okay, so that way these are the designs in the laboratory. The people, some of the reports I am going to share for the next few slides. So this way, they have started the nano donut by the peptides. Nano donuts, you see. So the molecular level donuts. So they have prepared with the help of the amino acid oligopeptides. They have prepared, then they publish. Okay, then nano rope. They have prepared with the help of amino acids. They have prepared. nano, nano rope. So this way, then we are designing something in the laboratory. Molecular level designs we are playing with the help of with a microscope, atomic force microscope or scanning electron microscope. Then we are imaging it to look like a rope. This peptide molecule is to look like a rope. Then origami. There as well as the Stanford, the California Institute of Technology, Caltech. So they have prepared the DNA origami. Using the DNA molecule, they are playing with origami. Origami usually it is from Japan. Kami means paper. So this way they will play. Most of the Japanese kids they will play with the origami. So that way they are mimicking same thing in the laboratory with the help of DNA. So these are the biomolecular design that people are the innovative way they are being. Then the paper sensor. This one is provided by the Whitesides, Harvard University. So he is preparing the color sensor, colorimetry sensor in the paper, very cheaper one. It's a matter of $1. Then he is providing the sensor. Using this sensor, then you can detect the glucose and protein level from your blood. So this way, these are the invention, these are the innovation is motivating us to do something for science. Okay, then the one more thing is which is our from our laboratory. Then we have designed some and arginine and aspartic acid, arginine, alanine, aspartic acid, the amino acid is for the hydrogel preparation. Hydrogel preparation. Okay, this hydrogel radar 16. This is named as a radar 16. So this when I add the 0.5, when I add the 99.5 percentage of the water, 0.5 percentage of this peptide, it becomes a gel, hydrogel. It will be consumed 99.5 percentage of the water. Okay, it becomes a big gel. Okay, where you can apply this one now, right now, the contact lens, the people are using for the contact lens. This way the design is very very important. This one is the design in the laboratory, in our laboratory, but now is used in the contact lens application. So then we are also attaching, since why I am showing this peptides and those things, we are using with some nano level the self assembly pattern. Then what we are doing, whatever was the donate and rope and those things is comes in the nano level, the pattern will be existing. Okay, so this way next time move on to the marine source, how the marine source is very useful for the pharmaceutical products. Okay, in this pharmaceutical products we are adding some nanomaterial over this to enhance the property performance of the marine source material, particularly for the antiviral, antimicrobial, antifungal. This is very much useful. Okay, so this way we are going to show, I'm going to show some of the slides, particularly what are the marine products is very useful. So from the marine products, so most of the drugs is comes from the marine products, and then as well as whatever the waste material from the sea waste, actually, then what I am concentrating the sea waste, I am bringing the sea waste and then I'm extracting from the sea waste. I'm using the extract for the different application. There is a medicinal value is existing. So to enhance the performance, I am adding the respective nanoparticle, silver nanoparticle, gold nanoparticle, some places. Some agri application, I am using the silica nanoparticle. Okay, this way I'm different nanoparticle I'm utilizing for the different application. Okay, there is a lot of the reports is existing. So marine environment is a big source of molecular probes. Then then as well as there is a very huge nutrition value is existing in the ocean. So from this you can take many things, algae and the tunicates, sponges, actinomyces, the many things you can take out from the marine. From this, then you can choose peptides, alkaloids, polyketide, polyphenol. So this way, then you can get extraction from this. There is very good medicinal value as well as. So these are the marriage. So I am playing particularly with these cells. As you know, this is a chitosan is taken from from the cells. Okay, the chitosan is very good antimicrobial property. So I am not only using chitosan, I am using adding the nanoparticle over this in situ way. Then I am preparing the nanoparticles, and then the last the lecture I used the gold nanoparticle over the chitosan, then I prepared the silver nanoparticle over the chitosan. So this way, not only chitosan, the other protein molecule, protein also you can derive, can extract from this the marine waste. So then as well as already the pharmacy people, they are preparing the anti-cancer drugs from the natural source. As you know, most of these medicines is derived from the natural source, particularly marine source, the plant source. Okay, this way, this is one of the interesting innovative product, which is a startup product, which is invented by Imperial College London. I think you might be heard about this. This is it was published a few years before. So they have taken the plants seaweed edible plow from marine source, edible water plow from the marine source. You can swallow the edible water plow, and then it is actually the water is covered by the seaweed, 100% seaweed. Okay, it's the biodegradable one, which is flavored and colored, then as well as fresh, to avoid the PET bottle, to avoid the plastics that people are using this kind of innovative product, which is also a startup product. So from the Imperial College, just I will show that. Yeah, this way, these are the innovation is inspiring us to different applications. Some of the application we did in the laboratory as academic report. So particularly, I worked the melamine detections in the raw milk. Usually, the nowadays the milk is adulterated by the urea. Usually, we'll say urea. The urea is nothing but melamine. Okay, so this adulteration, whether it's able to detect whether our milk is contaminated, adulterated by melamine. So this way, we have fabricated some device. So from that, this is L-arginine based AG nanoparticle, which is uh, nanoparticle, which is when it is when the melamine is present in the milk, it will show some color change. Previously, it was one color. Once it's bind with melamine, it will show the different color. So this way, then we have designed melamine detection this is a laboratory report. Okay, some more reports is published by some other group. They use cyclodextrin functionalized agent on a particular for the melamine detection. So the same way, when you have this kind of the noble metals, uh, noble nanometals, so certainly you can prepare some color sensor as I discussed before. Hmm. So not only that, dopamine, other one of the chemicals is dopamine, which is very useful for our neuro, the when it is the quantity of the dopamine is varied, we will be getting some neuro disorder. So to want to check the quantity of whether availability and quantity of the dopamine in fluids. So and on that basis, then we have developed the L-cysteine based aging nanoparticles to detect the dopamine. So qualitatively and quantitatively whether it's available in the solution. What we did in the man-made dopamine solution. So the aim of this project to detect the neurofluids, whether it's dopamine is existing or not, what is the quantity of the dopamine is existing. So this way we have designed not only silver nanoparticle, we worked with the AU nanoparticle, then we worked with the AU AG nanoparticle. So this way then we have exactly then we have derived some good the device to detect the dopamine. And the other side, to find out the six pheromones in the animals. Then we have used L-tyrosine capped cellular nanoparticle. Usually, why we need why we want to detect the six pheromones. So usually, when you go for the buffalo. So when you go for the cow, everyone knows that will give some sound to for the mating. Then we can able to identify. Okay, but the buffalo is very difficult. It is hiding. It is very difficult to the heat. That is heat. We don't know when it is need the mating. So that way it is we are losing the reproduction of the buffalo, production of buffalo. So when you want to have the more milk, then we supposed to most of the North India people they have the buffalo because they have the quantity of the milk is more, quality of the milk also is good for the buffalo. So that way this device is very helpful for the enhance the reproduction of the buffalo. So from the urine then we can able to identify whether it's ready for and whether that is named as a heat, it's ready for mat or not. Okay, instead of bringing the blood, so whether it's possible to detect these things over the urine. So that way the surface plasma based solar nanoparticles we have prepared, then we successfully we have detected the heat of buffalo. So this way, then we always keep engaged for the community-based, where whatever the things is very useful for the community day-to-day life, whether it's possible. So that way, most of our laboratory report is coming on this way. Okay. The next, then we have prepared some of the gold cream, which is the base materials, the solar nanoparticle, which is solar nanoparticle is based on the Cassia auriculata, which is the avarum flower. The extract is taken from the avarum flower. So then we have prepared the facial cold cream. Okay, so this is control the clinical pathogens. So this way, and then we want to control the microbial infection over the skin. Then we have used the our flower based nanoparticles. One of the component in the cream, which is very well is control the pathogen, the microbial infection over the skin. Okay, so not only that, then we use some microbicidal tissue paper. The tissue paper instead of the empty tissue paper. Usually the tissue paper we will go with the tincture, then we will wipe for the wound usually. Is it? So that way we want to avoid that one. Why don't we the implant some of the microbicidal over the paper. That is called the microbicidal paper. Okay, the paper itself it will be cure, it will be clean the wound, wipe the wound, not only empty paper. So this way we have designed, so that way the microbicidal tissue paper we have prepared with the help of the silver nanoparticle. The silver nanoparticle is prepared from green sources. Hmm. So other side is the graphene, as I told you, know, the CNT, carbon nanotubes. Okay, there is a rich material which is existing in agriculture waste. These are unrevealed information is existing. From the agriculture, this is the purest graphene material, 100% purest graphene material. You can get it from this agriculture waste. This is from particularly for the coconut cell. This is a recent the invention. The people are proven this. We need to take this the coconut shell for the graphene preparation, because as I told you before, the graphene is one of the richest source of energy material you can derive from the graphene. So that way, these are the interesting news is inspiring us. Innovative news is inspiring us to bring something from the laboratory to the market. Okay, so that way, I don't want to discuss that. Yeah. So that way, then I will slowly moving to the startup. What is a startup? I think you all, the faculty members is familiar. The startup is nothing but start something from the lab to market. What we have given slogan, lab to market. Whether whatever so far I discussed, whether it's possible to bring the market, it is very tough, because we want to get the customer, we want to impress the customer. It is very typical job. Okay, once you impress the customer with any one of the products so far I discussed, so you are the successful entrepreneur. Okay, so that way the startup is one of the, always our startup people will be sitting over the incubation. That is why they named as the incubation. Okay, once the material will be working well, whether the material will be reach the customer can give the good feedback. So these are the things is keep on going on in the incubation cell. That is why each college, your college might be have the incubation cell. So each college they have the each university nowadays it's a compulsory right now. The the UGC, EAECT is make it compulsory for each college supposed to run the incubation center. Okay, in the most of the startup people they will be sitting in the incubation center. They will discuss each other. They will keep on and talking about idea. Idea become the lab prototype is come up with the product in the market. Okay, before reach the market we want to do all those activities in the incubation center. So that way the nowadays is startup is emerged like anything the global level, uh, as well as Indian level. Okay, so this is who is a seed for this, who is a catalyst for this. Abdul Kalam is catalyst for this. So from that way, and his birthday is now we are celebrating his National Innovation Day. And that way, Kapila, we have started the Kapila, one of the program, and our based on our Abdul Kalam dream. Okay, so this way, whenever we are going for whenever you are preparing, you are invented some device, some medical device, then when you are dealing with a medical device, you are supposed to have some doctor. Okay, your collaborator, your partner with the doctor. Then only you can go to some of the medical device innovation. Okay, development by the researcher like you, so like us, like science people is a developer, but we want to start this problem from the doctor. Okay, so this way, then we have to have the network. Then only we can become the entrepreneur. Then the doctor and the researcher become the entrepreneur. Then we are looking for the investor. So by this way, then we can bring the product to the market. So this way, then we supposed to have the 400 problems, 200 prototypes, 60 patents, 20 products. You see, they started with the 400 problem. They have only end up with the 20 products. So this is what the culture of startup. It's very difficult to come up as well as. Okay, this way nowadays the medical device, the innovative program is going on in the around. This is the most of the report I have borrowed from IIT Bombay. I am also virtual incubator in IIT Bombay. So And this way, we are also part of the some of the devices we are working with them for the wound healing product. And so that way, I borrowed some of the slide from IIT Bombay. So each devices, they supposed to be some of the science people, chemistry, physics, some engineers, doctors. So these are the team will be connected together. They become the entrepreneur, and then they will look for the investor. They are sitting in the incubation, then they will look for the investor. Once investments come up, then they will bring our product to the market. So that way, then this kind of innovative product is right now is leading the market. Okay, so this is ways what we climb this best practice. So when you love, wherever needs, then where whoever is paid, that is whatever is good. So this way they have the we can make it as an innovation champion. So you see the next slide. These are the champions. So that way they become the champions. Okay, so that way the startup also, entrepreneurship roles also, entrepreneurship journey also is similar to that. Then only the best practice is very important to become the innovation champion. Uh, so that way, then I like to discuss some of the products in Arivia in my entrepreneur the program. Okay, so Arivia is we have the product segment is four types of product segments. One is for the pet animals, another one is for the poultry, another one is for the human health, another one is for agri. This is a way we have concentrated. So whether what we are trying to concentrate, whether is reduce these chemicals in the market, whether it's possible. These are the chemicals is now occupying the market, disrupting these chemicals, the disrupting these brands. These are the brands is playing this kind of toxic chemicals right now. Whether we minimize this, that way we are community-based product what we are having right now in our hand, based on these segments, four segments. Okay, so pet, farm, public health, and agriculture. Okay, so like this way, then we have designed the business model, particularly for the innovation, how our product is competitive advantage, as I said, the green chemistry, whether it's possible to strictly follow the green chemistry, because it's very interestingly, whenever we are preparing, we have the about dozen product in our based on the green chemistry. We are not at all other than water. We are not at all any of the material byproducts. We are not throw it away as a waste. We are consuming more water, but we are not at all is throw it away in the waste material or byproducts from our product. So that is the way, and then we have the very smart, innovative material what we have right now. So that way we are climbing that is a green. We are adopting the green chemistry and green technology. Then we are the source is marine source, particularly the marine source. So almost all the biopolymers we are deriving from the marine source, and there is good market drivers we have find out, and as well as very good market opportunities existing. So we have very good challenges. Without challenges, we cannot come up with we cannot stand with the product. Okay, we have very great challenges is existing in front of us. This is what the uh, RVA business model, the innovation model. Okay, so this is a platform technology what I have. So then each platform, each focusing plant, focusing product, we are using the different nanomaterials. The nanomaterial is enhancing the particular product. For example, when you go for agri-related products, then we will concentrate more on not in the silica. Right now, we are only concentrating silica. Other than silica, the people are using the different nanomaterials. Then the biofilm of bone management, then we are using the gold nanoparticles. all other antimicrobial paint and those products we are using the silver nanoparticles. So this way, then we have the medical grade product with the help of the and the nanomaterials. Okay, so this way, then whenever we are targeting the market size, so first the big round, then we have to have you have to have about the confident on your product first. Then this is a total available, then service available, the service obtainable. So this is the way. Then we will like that. That what I have shown the some slide before. We supposed to have thousands of invention, but we supposed to end up with only 10 or 5 product will be reach the market. So this way, it's a very challenging one. So when you talk about the startup and entrepreneurship journey, okay, then as well as you should have some tractions. So I have to get some certification, I have to be some incubation member of the incubation, I have to be some collaboration with IITs, some universities. So this way, then I supposed to have some traction. So once you have the traction, then certainly then your product will be getting more weightage, will get attracted by the customer. So that way, the traction also is very important in the part of the journey in the entrepreneur journey. Okay, so then this what is antimicrobial paint? Antimicrobial, which is comes along with the biopolymers, comes with the silver is part of it. When you ask silver is whether is because what we are using the silver is very poor ppm. We are maintaining the very less whatever the EPA standard. We are using less than what they have the EPA standard. Okay, this way we are with even without nanoparticle, this product is not working efficiently. That is why the nanoparticle is essential. Whenever we are using this kind of outside application, we are using the silver nanoparticle. When you go for burn wound dressings, we are using gold nanoparticle. Then we go for the agri application, we are using the silicon nanoparticle. That way, place to place, we are changing the nanoparticles, the category of nanoparticles. The respective nanoparticle is taking role for the best performance. You see, so even the pandemic time, whenever we touch, whenever then we are not, we have fully covered. That is why the viral is very dangerous. But fortunately, our polymer material it will be working against the virus, working against the fungal, working against antimicrobial. Okay, so this way we have designed some of the antimicrobial paint. Particularly these things is very essential for hospital, and the most of the place the handle will be infected by other people. So when you spray, then it will kill the germs, and then you will be getting the infection pre-handle. Okay, this way then we have designed, then we are providing the our product. Okay, so then as I said, the wound care management. We have some one of the products for the wound care management, which is comes with gold nanoparticles. Biopolymer is attached with the gold nanoparticles. So this way, there is very good the wound management is taking place. uh, you see this is our product, this is a positive control, this is a negative control. This way, then as well as one more interesting things which is existing in our product is a tissue. It will be regeneration of the tissues. No, do the scar is disappeared. Scar, whenever you will get the wound, you will be having like scar no over the skin. This scar is disappeared by using our product. So this way, we fortunately it was happened. So when you take the natural product has amino acids, some organic acids, then we are adding some nanoparticles, suitable nanoparticles. So this way, then we are playing well with wound healing quickly. So even without scare. Okay, this way then the right down we named as a Tem Skin. This kind of product is going to reach the market soon. So that way it's 99.99% is natural. So there is a very good the market is existing in the global level. The next one is then what we have the product for the udder care. So udder care means then otherwise this is a kind of mastitis. One of the issues is comes in the udder. So mastitis due to the environmental bacteria. After milking, all the invaded the bacteria. After milking, it will be invaded towards the teeth. It will be infect the udder. Okay, so that way mastitis is a disease name is catch up. To prevent this, we have the solution. So due to this, then we are facing the 7,000 crore loss every year in India. To avoid this, then we have the product, then we are reaching the market right now to avoid this problem. So that way, then this is what our invention here taking place. Along with the polymer, we are introducing the suitable nanoparticle at a suitable level. So then these are the efficacies existing in our product. So that way, then we are leading to the market. Okay, so that way, then we are playing nanoparticles, biotechnology, and polymer technologies. Three are comprising that way. Then we are trying to prevent the mastitis infection. Okay, in the cow, particularly milking milk animals. Okay. So this way we have the proof of concept. We have tested with our product. This kill the 99.99% of the bacteria, spore forming bacteria. And we have tested in the field trial. So that way, then we have the proof. That way we are standing in the market. Okay. So like this way, then we put some cards over this. Then we are standing in the right now. Okay, so that way, not only that, the nanoparticle is nowadays, I think you might be heard. So their foliar application, then as well as soil application, they are using the nanomaterial in agriculture. Okay, but in the terms of nano fertilizers, nano biosensor, nano based remediation, nano pesticides, the people are right now they are using nowadays. Nano fertilizers, nano urea is very famous. The IFCO is selling the nano urea. So this way, the nanotechnology is playing major role for agriculture right now. That will one side is this enriching the soil, other side is a foliar application means the plant growth. So that way, both side is contributing nanotechnology. Okay, so then when you ask what type of nanoparticle is particularly is helpful for this kind of things, silica. When you talk about the soil application is silica. Other side, iron, copper, zinc oxide, phosphorus, magnesium nanoparticle may be less than 5 nanometer. It's very useful for particularly for the agriculture application. So this way, this is playing the major role right now, nanomaterials in agriculture application. So, okay, this way, then, as I said before, so sensor also is playing the major role in the different way, mastitis detection. So then, as well as I told you, to cure the disease, not only cure the disease, detection of disease. A pregnancy test, as I said in the buffalo. So it's very difficult to identify mastitis detection, pathogen detection, viral detection, because this viral detection is very useful for the pandemic time, COVID-19 kit. So this way, the people are right now is playing a major role with the help of nanomaterials, along with bio, along with organic molecules or biomolecules or polymer molecules. So that way, then we are preparing some templates to detect the not only animal health nowadays is very famous for even the human health also. So this way, then we are our company, our firm is concentrating more on different issues. The community based, as I said before, community based, animal based, environmental based, uh, the agrarian based. Then we are working that way. Then we are happy. We are contributing something for the community with the help of science. So we are providing science. We are the science people. We are using this as a proper science without harmful. So we are minimizing the nanoparticle quantity as well as it is not supposed to be in future. It is not supposed to be hazardous for the soil. Okay, so that way we are designing. You see, the one of the recent news which is published by the CSE, and then they don't we don't have the method to identify the honey adulteration. I think it's a very pathetic news which is existing in India. They have tested whatever the instrument we have in India. It is very difficult to find out whether the honey is adulterated or not. But once it's taken this brand, this samples to the German, from the German they have tested, then they have identified this all the sugar syrup is added over the honey. It's not natural one. It is actually added sugar. So that way it is a recent news I have catch up from the CSE in New Delhi. This is one of the private agency for the environmental science. They have the separate institute which is existing in New Delhi. So in this way, then this is what our right now our level. But even though we have all infrastructure, but even though we are not able to identify the adulteration of the honey in India. This is what the right way right now our level. Okay, so for that I am requesting you the faculty members to encourage the lot of research activities with your students to lot of unrevealed area, untouched area is existing in front of us, around us. Okay, nowadays is the waste material, decomposition of the waste material, one of the huge headache for us. It is nobody's properly addressing. So we are seeing a lot of news. We are seeing a lot of reports. What we are contributing. This is the pathetic way what we are having right now in the condition. For that, just I want to insist the young minds of the faculty member to think about this kind of things is existing in India right now. Okay, that way you start some club in your colleges. You start some club. This is a club is started in MIT. Whenever I want to see some example, I will go to the MIT website. Then I will see some of the sites. So Sol Club or like environmental club, Sol Club, Innovation Club, Startup Club. Like this, you encourage your students to think out of classroom to encourage your students to get some contribution to the community from our science. Okay, and this I think close how they are. Okay, thank you. So with this, then I'm closing my lecture. This is what the recently then our farm is got the best startup in Tamil Nadu. So I'm proud to share this news with you. 2 months before we have start, we have got the award from our honorable chief minister. I'm standing here. So almost more than 1,500 applications they have received. We have out of that we have 30 incubators, 30 innovators. Then we have got award from the Tamil Nadu. So in Tamil Nadu. So that way, then we are standing with the one of the product that is taking care of udder in the milk animals. Mm. So with this, then we have got a lot of awards from the TETAL award we have got recently from and the Startup India in New Delhi. Then as well as we are the best startup then recognized by the CAI from Trichy. This way we have got a lot of the recognition, and since that will show the quality of our product. And so efficiency of our product. That way, then we are proud to stand to inform in front of you. Thank you very much for your the patience. I believe that then I engaged you some science, some technology, some nanotechnology, then as well as a startup entrepreneur the experience I shared. I hope you enjoyed this the lecture. Thank you very much. Thank you. Bye.
Professor, we wait for some discussion session.
Yeah, yeah, sure.
So, participant, any question?
Sir, I'm Chitra.
Yeah, tell me, ma'am.
Thank you so much, sir, for such an informative session and which I never heard before. And you have inspired me a lot for the startup.
Thank you,
So
ma'am.
I have one doubt, sir.
Yeah,
I am so interested in
I'm not hearing, madam.
Ma'am, your voice not audible.
Yeah.
is it for tasteful purpose or to satisfy the thirst?
Which one, madam?
Water blobs, sir. That edible
What
water.
it is a thirst, madam. Because we want to avoid the pet bottle. We want to
Okay.
avoid wherever you go, you can carry this ball, then you can drink wherever you need to drink water, then you can swallow that one. That way.
So one blob is equal to how
Um,
much ml
yeah,
it
yeah,
will
maybe
conserve?
because it's a small ball, because for the design, for the carrying purpose, they have prepared like this. And
Yes,
then
sir.
you can pack it many balls over your back. Then whenever you feel, then you can drink.
Like
You can
chocolates.
yeah, yeah, like yeah. Yeah, that way, that is a Imperial College invention. I think it's a real invention from UK.
Sir, is it possible for us to produce such one in our labs?
Yeah, yes, it's possible, madam. It's nothing but inside is water, outside is seaweed. They have the select edible seaweed they have covered. They have some
Okay.
machinery from that they have covered. It is possible, madam. Edible seaweed, which is existing in our, we have vast the seashore, no? Certainly you can you can do. You go
Yes.
and visit the Imperial College website, you go and visit, then you can get more information about this, the water flower. And then and that way, then you can get some information about the particular, what is a particular seaweed they have used. So that way
Yes.
we can mimic in our place. Then you can modify it. You can modify it over the whatever the present invention. You can, if you are interested, you can modify it that way, then your product will get the different value.
Yes, sir.
Yeah,
And then
certainly.
for all the nano engineered particles, how to check the safety and
Yeah, that is a challenging one, madam. Wherever you go, there is a issues are coming. Wherever you go, there issues are. When you go for the disinfectant, the people are always the EPA. They will put the brake whenever we bring the product. But there is a TikTok way. Then we are facing a lot of challenges here and there. And that is the way, then we are minimizing the quantity of the nanoparticle. Then as well as playing the role with the size of the nanoparticle, as well as whatever for our medicinal application, what we are having, most of the nanoparticle size is more than 100 nanometer. So what is the safety says, if you deal with less than 100 nanometer, that may be penetrate into the cell structure. That is why what we are adopting in a particularly for RVA, what we are adopting our nanoparticle size is more than 100 nanometer. So those 120 nanometer approximately we are maintaining. So those 120 nanometer will not penetrate in the cell membrane. That will not disturb the cell membrane. Real, for example, our living things cell membrane. That is the way we have designed. So that way there is a challenges is existing. I agree, but we are
okay.
whenever we are once is introduced the plastic, So we are ready to invert everyone we used. Now it is a plastic itself is a big challenge. So that is the way we are going back to the biodegradable plastic. So that way, then we are fine tuned with the size of the nanoparticle. That way, then we are somehow we are fulfilling that kind of challenges, environmental challenges.
Yes, sir. Thank you, sir. And in our department, we have synthesized so many nanoparticles through green synthesis methods. And
Okay.
as a MSc project, I have also tried to, with the help of chemistry department, we have prepared soap first, and then we have incorporated that copper nanoparticles into that one. And
Mm,
it
mm.
showed excellent bactericidal activity.
Yes,
But
yes, yes.
we don't know how to commercialize it. Only
Yeah,
after hearing you, I got
yeah,
interest.
yeah. I think which college, madam? You are from which
MGR
Adhiman?
College, same Adiyaman campus, sir. Arts
Okay.
College.
I think usually nowadays is I think maybe our head of the department, our principal knows very well. But each college they supposed to have the incubation center. Nowadays, I am guiding lot of incubation center over Trichy because
Yes,
nowadays in the Kaveri college, then they have the incubation. That is a private arts college actually. They have a very nice incubation center that is existing in Trichy. Why not
okay.
you? So that
I am
way.
also belong
Mm.
to Trichy only. My native is
Yeah,
Trichy.
okay. Okay, that way
Uh,
then you can do very well because since you are in the Adiman College Hosur, but you are
so we
nearby.
have started that innovation incubation cell also in our college, sir. Now we have
Yeah, I
inaugurated.
think you can promote, madam. You become the
Yes, sir.
coordinator. You can promote, madam. So that
I
is
will
the way.
approach you, sir, later.
Yeah, certainly.
Yes, sir.
Because nowadays, I think the accreditation is comes no. Maybe the college, I think as a faculty members knows very well, the accreditation now is a part of the mark for the Innovation Council. If you have
Yes,
the
sir.
Innovation Council, Institute of Innovation Council member, you have good, the part of the mark for the accreditation, NAC
Yes, sir.
accreditation. Okay, this is a compulsory now. That is why
Yes,
it's
sir.
a familiar. Now every college is familiar. Incubation center is familiar. Not only university, not only IITs, I believe.
Yes, sir. Thank you so much, sir. And I
Okay.
also thank Sundaram, sir, for giving me this excellent opportunity. Thank you, sir.
Thank you. Thank you.
Any other doubts, participant? So, what are the things we observed in advanced NMR? Sir?
Sir, yeah, tell me, sir. You are asking me.
So, what are the information we getting from advanced NMR?
Advanced
Advanced NMR.
NMR, advanced NMR. Advanced NMR, then you can be, because since I am not so familiar with the, because whenever I go for the whenever I prepare the peptides, I use the NMR. And then so for the specific the amino acid which is existing in this oligopeptides or not, for that I have characterized with NMR. I'm not handled, but I given to someone, the technician, then I use the NMR. From that NMR, then you can, from the proton, from the proton, then I can able to calculate what are the types of amino acid which is existing over this. So that way, I utilize the NMR for the identification of the respective amino acid. I know the molecular weight of the compound. After that, I will go for the each organic block, so which is having the proton. So that way, I use a proton NMR, particularly proton NMR.
So, participant, any doubts? So, okay, Professor. Thank you very much for your wonderful. What we learned some new things, new ideas from your presentation.
Yeah,
Then
thank you, sir.
we learned some how do you make some how do you say that business point of view.
Yeah, yeah, yeah. That is,
If you come to offline means that I'm very much happy, but
yeah, yeah, yeah.
you're having a,
Well,
more busy
that
schedule.
was so
I think.
I'm sorry for that because this is a purely for faculty development program, but just I want to motivate the faculty members. That is the way I design my lecture like this. But this is what I'm doing right now. That is why I explained whatever the experience I had, then I explained.
Thank you
Anyway,
very much,
thank you.
Professor. Thank you very much.
Thank you. Thank you. Thank you. Thank you very much, sir. Bye. Bye.